Okay, so is that clear? And I'm sorry again. If this is clear, then we'll move ahead. Okay.
Yes, clear.
Okay, fine. Anyone else has any question? Like only one yes, clear, and nothing else. Lectures and all the records and all these notes, it won't be an issue. You'll get it, and there are even better notes on the on anywhere you can. I mean, you can just Google about this and you'll find better notes. Okay, so clear one. If the response is, actually that whoever said that you can extend, can you please not extend the time? So I'd say like if you guys respond faster, we'll not extend the time. We'll not try to. Like the class moves faster. Anyway, so like you don't have to remember this number, not this number. You just have to remember its size and that it's 32 bits. Okay. And even in double, the number is even bigger, something like 10 to the power 4, something above 3 digits power. So I'm not writing that. You can just search it, but the precision is 16 digits. Okay. And this precision is 7 digits. So it can precisely store and precisely represent the number of 7 digits, means after the decimal point. But if you type more than that, there will be inaccuracies. Okay. And one more thing is that last day I wrote here boolean, but it's bool. Okay, that is not probably a big deal. So like integer is represented as a int in C++. Similarly, boolean in Java is represented as boolean, but here it's called bool. Okay, one more thing just do quickly. Just give me 1 second. That I'll just create a mistakes dot text. I will just keep a record of my mistakes. It's 2 currently because last day I multiplied 0 with 2. Okay, no, something important actually happened. So the floats range was last day what I told, floats range was incorrect. This is the correct range. Okay. Yeah, I was just correcting one mistake that I did, and another mistake was already corrected. That was I multiplied 0 into 2 and I wrote 2, but it was 0, but I corrected that. But this I did not correct. The range is this. And how this range is calculated is based on a convention called IEEE 754. Okay, and explaining that would take a whole class, so we are not explaining that. Okay, is that clear, Sakshi? Can we move ahead? 7 minutes already gone. Sakshi, you have to respond. Like, are you like on the same page with others? No response. Okay, yes, fine, 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 fine. Okay, so what we're doing is till this we did the logical not operator. We saw that it flips the condition. Okay, so then we have comparison operators. Okay, so first is equals to. So what equals to does is it checks two operands. It checks the left hand side with the right hand side. If both are equal, like it's written, it checks two operands. Uh, if two operands have the same value, and returns true only if they are same. Okay, since I have to merge so many things in my screen and also have to make my font bigger, that's why I can't store all of this in a single, so I have to slide it. Okay, so we'll quickly see how this works. Okay, let's see. We'll come to that. I was just testing. Never mind. Int b equals to 7. We'll see out. So what do you guys think will be the output of this? uh, we are checking both values, and as it was said, like if the values are same, then it will return true, otherwise it will return false. Okay, so 0 0, yes, right, those who say 0 is absolutely correct. Fine, nice. Okay, so we'll just see the other thing as well as quickly as we can. So it's 1. Fine. For this int, for int it works the same, but we'll see some other conditions too. Like you can use this with int float double char, and sorry, this is not true. This is, why did I wrote true? I don't know. Anyways, I've written all this stuff before, so we can save some time and probably not extend the class. Okay, so this equals to is, but this equals to can also check between different types. Like let's say char b. Okay, so we score like 6 on. So what do you think will be the output here now? Any suggestions? One. Okay. One. Okay. Two ones.
One, I hope.
Yeah. One more. One. Three. Think no one wants to let's respond, so we'll see. Yeah, it's one. So how this works is char b equals to 6 stores some character. We'll come into characters in a second or in a minute or so, because like I said, some more info is needed about data types. Data types were not completed last day, so we have to see characters. Characters is also a very important data type, and there are things that you'll find, like some tips and tricks, some uh, things that you'll see today. Okay, we'll come to that. But so how this works is uh, this converts the other type as well to the similar type of the left hand value. So a was int, it converted character to that similar value. So it converted character, typecasted character to int, and so int had 6 in it, and then it checked, saw 6 equals to 6, it returned 1. So what would happen if we do float 6 comma 0? Now what do you think? Any answers, guys? Like anything you think you can type.
One,
Like we would not mark you
one
based on
maybe.
this. Yeah, okay, one. One, one. Everyone one. Only Iram is saying 0. Let's see. Yeah, nice. So whoever said one got the concept that according to the right hand value, it's typecast the other value to the similar value of the right hand value to the similar data type of the right hand type, and then checks, sees if the values are similar, then returns true if they are similar, returns false if they are not similar. So this was like our equals to. So one thing I would like to like caution all of you, that when writing your program in your copy, like a lot of people make this mistake that they don't write equals to and only write equals to. So be very careful while you're writing your if statements and whatever you're writing, while wherever you're using checking this value, like in Python you have to write equals to. So be careful while writing in your copy, because this is a mistake a lot of people make. Even I made a lot of times. That's why I'm saying uh, make sure to check those if conditions, while conditions, wherever your conditions are, that you have typed both equal to, not one. Okay, even in program sometimes you uh, sometimes I failed to type the second equals to and I got the error, I solved it. But in your copy you can't solve it, right? You have to submit it. The copy won't give you a compilation error that this equals to this assignment operator does not work as what you're thinking. Okay, so I know I'm going a bit fast, but like we're trying to complete within the extended time. That's why. But I'll still ask, like if you have doubts, you can ask. So I don't think there are any doubts till now, because everyone is
Hello,
answering
bhaiya.
probably. Yeah,
A character can be letter, like A, B, C,
character
D.
character is a letter. We are coming to characters. Just wait a bit. We'll check this
Okay.
less than and greater than, and then we'll jump back to characters, then we'll come back to bitwise, and that would conclude our class. If we have some time, we'll learn what is decision making. So that's the flow. Okay, fine. So less than, so probably less than is very easy. Like what can I even explain about less than? So still just read the definition. It returns true if the left operand is less than the right operand. Okay. Okay, let's just say, to make it more grammatically suitable. And greater than, it returns true if the right of sorry, this will be left operand is greater than the right operand. I make a lot of mistakes in left and right. Anyways, so let's say we'll just see a simple example, because like this is literally simple class 1 to maths. So uh, I think you all agree that this will return true. That is one, right?
Yes.
Okay, just one yes. Like you have to see typing yes. I know it may take some energy out of you, but this like this makes you a bit proactive and gets you into the mood, right? So try to type as why I'm asking the question. Try to type. It will be better. So we run this, we get 1. Nice and easy. So we shift this, sorry, a greater than b, and we get 0. Probably nothing unexpected here. I mean, why did I say probably? I mean nothing unexpected here. Okay, so let's see. Okay, we saw greater than and less than work. So we'll now go to characters. Wait a second. Okay, where characters? Yeah, nice here. So character size is 1 byte. It stores 8 bits. Range is -128 to 127. But characters, as the name says, it should store letters, right? So how does this work? I've only said the range is this to this. So what it does is it stores values, but to each value it maps a symbol, and that symbol table we'll see right now. So I seeing the float range. Okay, so this is a character table. So it starts from 0, goes to 127. Every number is assigned a character. Starts from here, goes here, and then this A starts from 65, then ends at 90. 97 is smaller A, and then this ends at 122. So here you have to note a few things. So like I'll write this, but it will be better if you note. Okay. So 0 to 31, these characters are called control characters. Okay. Even I'm writing on my notepad because it helps. I don't know why. Maybe because I'm still a student and not a teacher. Okay. And then rest of the characters from 32 to 127 are all printable characters. Okay. So what does control characters mean exactly? So control characters are something that you can't print, but using that you can what say modify the cursor of the console. Like there is something called a carriage return. I don't exactly know what the ASCII corresponding to that is, but it returns the cursor to the beginning of the line. I mean beginning of the console. Okay, and you can see that 9 ASCII. Okay, wait, 9 represents tab. Okay, so you all know what a tab is. It's a bunch of spaces. It's not exactly bunch of spaces. It's exactly 8 spaces. Okay, starting from the line where you are, it goes to the next 8 where 8 is represented in the screen. Show you a example. So this is the starting. Let's say if we hit tab, we go here. There are like 1 2. Okay, this will not work here, but in the console it represents 8. In here it's just like 4 spaces, but in the console it goes to the next 8 uh, wherever 8 is stored. So okay, if you start from here and if you tab, see it just goes 1. So how many is this? 1 2 3 4. Okay, we are here or here. Wait a second. So here it is 4. See, if I tap from here, I go here. Tap 4 more. But if I am here and I tap and I go this, but it does not move 4 because like this line is 4, another 4. So wherever you tab at, the cursor sees where the next 4 I can get, and it goes to that place. But in while doing in the console, it goes to 8 spaces. Okay, so we'll see that in a minute. Okay, so where were we? Okay, so 0 to 31 is control characters, and 32 to rest are printable characters. Printable characters mean that we can print them in the console. Fine. So here you have to and now see. Remember two things: that A starts from 65 and ends at 90, and capital A starts from 65 and ends at 90. Small a starts from 97 and ends at 122. Okay, so remember these two things because you'd need this. Now this all these numbers 0 to 127, these are called ASCII values. Okay, so now we start writing. Lost our chat screen. So whatever I did was just what I explained. Each value from 0 to 127 is assigned a character. The numbers, okay, the numbers from 0 to 127 are called ASCII values. The ASCII values from 0 to 31 are called control characters. The ASCII values from 132 to 127 are called printable characters. Okay, so fine. Any questions till now? You should probably have a question, but I'll answer that myself if you don't ask it. No issues. So any questions? No, yes. Maybe uh, speaking too fast and everyone left. Don't know. Don't see a single response now. Guys, if you have questions, you can ask. No issues. Like, just type. Okay. No, no, two no's anymore. Anything. If you even want to share something, you can do that as well. No issues. वापस बोले एक बार. Monal, which part? Any part or the full part? Like from the beginning. I know I'm going a bit fast today. Monal, which part exactly? Okay, cat data type entire. So, okay, first let me reduce my speed. I think that will help. Okay, so the problem is that the louder I try to speak, the faster I get. I don't know why. I try to speak softer so I can go slower. Okay. Anyways, so as I said, that cat's size is 1 byte. Okay, समझ नहीं आया. Okay, I'm going again. Going again. No issues. So okay, you can understand that cat size is 1 byte. So 1 byte equals to 8 bits. Till this is clear. And then, as I said, that we find the range with this formula, like minus 2 to the power n to 2 to the power n minus 1. So minus 2 to the power 7 is 128, and minus 2 to the power 7 minus 1 is 127. Clear till this? Monal, Iram. Okay, fine. Okay, so we forget the minus part for now. What I said is, like, if this is a character, then it should store letters, right? Uh, that's what the name suggests. So what's the point of storing values? We can do that with int as well. So what character does is that for each value, it stores a character. For each number, it stores a character. Even the minus part has characters as well, but I'm showing that a bit later. So wait for that. So we just consider positive part for now. Okay, 0 to 127. So let me tell you. And then I showed you this table actually. Can you see the screen? First tell me that. Manish, Pavan, if they don't open the mic, you have to say that. Is this part
Yes,
visible?
yes,
Yes.
yes.
Okay, okay.
But can you
Yes,
zoom it a
it's
little
visible.
bit?
Okay, Zoom. Okay, Zoom. Maybe that was the issue. I don't know. Okay,
Yeah,
Yeah,
so
it's
as you
right,
can,
visible.
right.
okay, so as you can see, like this table starts from 0 to 127. We said we are considering the positive part for now, so it goes from 0 to 127. Okay, uh, so you see, like every value has a character assigned to it. So this, what this DEC means is that the decimal value. Okay, hex means the hexadecimal, and oct means the octal. So like decimal value is not that point. Decimal is a representation that we use normally. Like 1 to 9, we use 1 to 9 to represent our numbers. That is the decimal system of representation. Sorry, 0 to 9. We use 0 to 9 to represent our numbers normally. That is the decimal system of representation. So this starts from 0. You see everything has a character assigned to it. This 9 has a tab. So tab is the only thing I think you can recognize from here. Else this left feed, bell, all this are unknown. Even to me, I don't know all this. Don't worry. I know only like tab. I can also only recognize tab and null. So okay, so this is important as well. So null is absolutely a null. It's nothing. It's not a space. Don't confuse null with space. Null is absolutely nothing, no existence. Okay, we use this while representing our strings. So remember that 0 is null. Okay, now you can see, like, so after that I said that from 0 to 31 are called control characters. So all characters from 0 to 31 are called control characters. Why? Because this can't be printed. they can only be used to modify the cursor on the console. So like to move the console left, right, return back to the starting position and all that. Okay, so probably search all this. Maybe I need to. Okay, that carriage return I was saying, I got it. This CR is the carriage return that I was talking about. So it just takes the cursor to the absolute beginning and removes all the things that are printed on the console. Okay, so this 0 to 1, 0 to 31 are control characters, but there is one exception, like this tab. Tab you can print on your console. It prints some spaces. Okay, like a number of spaces. We'll see how many number exactly. So wait for that. For now, you can see like it prints four spaces on this text text type, but in the console we'll see. So now from 32 to rest, like then I said like 32 to 127 are called printable characters. So printable characters, exactly as the name suggests, that it prints some value on the console. So if you write 32 and see out that char 32, see out that, you'd see a space. If you write char c equals to 33, see out that, you'd see a semicolon. Sorry, exclamation mark. What am I even saying? 34, exactly the same. You'd see quotation, hash, dollar, like that. So that's all I said, actually, nothing else. So what do you think, Monal and Iram? Is it now clear? Or do you have questions? Okay, don't say it's clear just because I explained it the second time. If you still have questions, you can ask. Like the motto of our session is not that to complete the syllabus. The motto of session is whatever we're learning, we'll learn it clearly. Even if it means like we can extend that class for 5 minutes. Probably those who have some work, they can leave and check the recording later, I guess. But we'll not extend like we did last time. So we'll try to finish it in time. So everyone's opinion is like taken. Can you write a program? Yes, that is the thing I'll do. Exactly, I'll do now. Sure, sure. I was actually planning. That's why I asked that if you have doubts, then I was moving on to this. But you said you had doubts, so I had to show you. So let's say, okay. From this, select anything, like whatever you want, from 32 to 127. Chat anything, so that you you cannot say that I'm cheating and writing something. Okay, 41. Fine. What is 41? The right parenthesis. Fine. See. Okay. Just let me clear this and run this again so you can see it more properly. See. Fine, Monal. 61. Yeah, we'll do that as well. No issues. Just let me fix this a bit. Okay, 61. Nice. Equals to. Okay, we'll see what is 61. See, 61 is equals to, it got printed equals to. Let's print a tab as well. Let's see what happens. Testing. Okay, so it prints space, but we can't see that because there is nothing after that. So we'll print a name. See how big is this space compared to this space. That's what I was telling you all. This is this much and this is this much. So these are 8 spaces. I can't count here because the cursor won't let me, but you can trust me, this is 8. I mean, up to 7, this 8, and this is the 9th cell. Okay, this is the 9th cell, and these are the 8 spaces. Okay, so is this clear or you have any questions? Right one control. Yeah, I did with tab, right? I did with tab. Tab was a control character, but tab is also a printable character, so I can say I cheated a bit. But if I write a control character, you won't see anything. So what would be the point? Probably you can see a carriage return as well. I don't know. Yes. Uh, it goes to the beginning, prints a. So carriage return is not something we can print. What we can print one. Let's see what happens with one. But probably you won't see anything. See, nothing gets printed. It's just one. If you remove this one, you would see absolute empty. Okay, why is this printing a still? Wait a second. See, it printed nothing. Probably did not compile last time. got to clear all this and run it again just for you all. See, nothing is printed, absolutely nothing. These are not space. Okay, the console just jumps to the next line. So this line is, I can select all this. Nothing is actually printed here. How to see the ASCII code using the character? Nice question. So what character do you want me to store in this? Orgo, you will only answer me. But first tell me what character. Anyone can say, not Orgo actually. Anyone can say what character should I store? D? Okay, D. Fine. So D gets stored in here. Star. Okay, we'll go for star next time. First D. Okay, one by one. Can't do everything together, then it will become a string, not a character. Okay, as I said, string is a collection of characters. So we'll go to a text. So as I said, character stores numbers and numbers can also be stored as integer, right? So what do you think we should do here? Find a way to probably convert this to integer, right? And this is how you do it. Int, okay, what C, and now C, 68. Let's see what D is. D is 68, as you can see. Fine, Orgo. Okay, I'll explain this, how did this int occur, but let's just finish the data types and operators part. So this is called typecasting. You can convert a type to another type forcefully by writing the type name before that with brackets. Okay. Good thing my speed has slowed a bit. I was going really fast in the beginning. I hope now my speed is fine. Okay. So we saw 0 to 127. And I told you, remember this capital A's ASCII value is 65 and capital Z's ASCII value is 90. Small a is 97. Small z is 122. Even if you don't remember capital that Z part, if you just remember A, then you can add 25 to it and you'd get it. 25, why you ask? Because we have 26 letters, but already A is stored as 65. Then rest of the 25 would be stored and that gets it to 90. Yeah, typecast Monal Z. Monal knows a lot of things. Nice. So like, is there anyone who does not know any programming language and getting something in my class? Or is everyone who is answering already knows something? If there is anyone who did not know anything about programming before this and got something in my class, understood something, I'd like you to say yes. Okay, Ram, fine. Only one is a bit depressing number, but okay, maybe. Okay, me, two me's, three me's. Okay, fine. Anyways, okay. I know what you did there. Okay. Anyways, so remember this A is 65, capital A, and small a is 97. Okay. So now you are thinking probably then if we can already store 0 to 127, then what's the use of minus 128? But Sakshi, I talked to you last day when solving your doubt. You said like you have done C++ before. I guess you said that only. I don't remember really. But I think you are the one who was saying that I have done a bit of C++ before. Anyways, let's talk about this later. Let's right now see. So now we are talking about the negative part. So if everything can be stored in the positive part only, why do we need this? What's the use? The use is this. This is called the extended character set. Okay, probably have to zoom in. Okay, so this is called the extended character set. From 128 it stores to 258. A lot of weird characters that I don't know what they're used for. Probably this A, O, I. Other than that, and this N, this works in Spanish. So and probably some more. I don't know what use of this 208 to 217. I don't know. Anyways, might be some use, but whatever. So 128 to 255 are stored. Uh, okay, so this is the extended character set. 125, 128 to 255. Now probably your question is that, but Dada, we are storing minus 128 to minus 1 and you are storing all this in 128. How does this even work? Okay, for this you actually have to know 2's complement, but I know many of you may not know 2's complement, so I'll give you a very simple uh, explanation about this. Let me open my pen that I use for drawing. So my drawing would be really bad, but and even more worse because I'm using a mouse. Wait. Okay, wait. Okay, so this is a circle. This circle is joined, but सब भूल गए मैं. Okay. So this is a circle. This is joined, but I have not joined this to show you something. Otherwise, you won't be able to. Otherwise, I can represent if I join this. So see, let's say this is 0, and let's say this is min, and let's say this is max. Okay, so max is, as our range suggests, this 127, and min is minus 128. So we went till 127. Now we wrote 128. One second. Oh, sorry. Okay. So while I'm with this thing, I can't shift to the cursor, so we'll be staying in this page. Okay. So max is 127, as I said. Min is minus 128. So what happens when you try to store 128? See, first I'll show you the program only. Then I'll explain. That's better. That's how you learn properly. You know, the beautiful thing about computer programming is that everything you can verify in a second or in a minute, but you can't do this for other subjects. So see, we stored 128, but we weren't supposed to store 128 because the range is only till 127. Now we'll run. Okay, this, see, whatever this stores is, this stores this character, exactly this character, but it should not. Like the range is 127, so we'll print its ASCII value. Now you'd see what happens. See this, we get minus 128. So now I can explain you, I guess. Wait a second, where did I go? Yeah, is it still there? Yeah. So this was a max. We've added 1 to a max. What happens is, since this is a circle, I mean, this is not a circle. I'm just trying to uh, explain you by this circle. Okay. So this is our range. This is 0. This is min. This is max. So we add 1 with max. We go out of a range and we go to min. And our min is 1 minus 128. Our max was 127. We tried to go to, we added plus 1 to go to 128, but we went to the minimum most number because this works like a circle. This is the visual representation, but in reality, it works with something like 2's complement. So if you do like minus 128's complement, you'd see, wait, a bit messy. So wait a second. So probably should I go up with the 2's complement? I don't know, because how many of you know 2's complement? First, I need to know that. Wait a second. Oh man. Okay, so how many of you know 2's complement? I know. Fine. Any more? Me. Anyone that does not? If anyone that does not, then it's a problem. If you all know, then it's not a problem. Then I can explain easily. Not an issue. Anyone that does not? No one. Fine. Then I would go and I would explain. Fine. So what is 127 basically? I would have to show this in binary. So it's 7 bits of 1. Have I typed it correctly? 3 bits of 1 and 4 bits of 1, 7. Okay, typed it correctly. Fine. So this is 127. You convert this to decimal, you would get 127. Fine. So we go to 128. Okay. Oh, and it was 8 bits. So 0 in front. Remember, it was 8 bits. So we separate the first bit for negative number. Fine. So it was 0 since it's a positive. So once we go to 128, it becomes this. Now this is a negative number because the first bit is 1. Now if you know 2's complement and do 2's complement on this, it gives you minus 128, isn't it? Like anyone would like to contradict me that no Dada, you don't know 2's complement, this does not give minus 128. It gives something else. Anyone? No. Yes, no. Anything? Probably. Okay. Uh, like no one wants to say something. Chat. No response. Okay, wait. So 128 is this. I'll do the 2's complement, I guess. No one said that what would be the 2's complement regarding this, but everyone said they know 2's complement, isn't it? Okay, so still no response. So wait a second. Okay. How do I write the place values here? That's the problem. That's what I'm trying to figure out. See. Okay, if you know the 2's complement rule, that is, if you're doing 2's complement on this number, just a second. If we do 2's complement on this number, we first find the first one. This is the problem actually, that I have to add 0. I'll do that. I typed one more. Okay, you guys need time to do the 2's complement, or somewhere I'm going wrong. Okay, I'm doing the 2's complement. So the rule of the 2's complement is we find the first one bit, we keep that one bit as it is, move to the left of it, and flip all bits whatever they are. Okay, so if it's 0, we make it 1. I typed one more 0. If it's 1, we make it 0. So I did not want to explain this but you said you know 2's complement, so I am explaining. But if you don't have a good knowledge about 2's complement, this would be very hard to understand. Fine. So whatever. So now what we do is we convert this to decimal. So the decimal of this is like all zeros, and this is the 8-bit. So we do 2 to the power. Wait a second. I just have to count. Hmm. Why do I think that I wrote 9 bits? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I wrote a bit extra. Did I write extra here as well? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, wrote one more extra. Okay. This is really tough. Wait a second. The problem is that I can't align all this, so you guys get a better understanding. So 1, 2, 3, 4, 5, 6, 7. Yeah, it will come to 128, and it will be a minus, but I have to explain everyone. So what I'm trying to do is I'm trying to align this, but I'm messing this up a bit. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is 8. This is fine. 1, 2, 3, 4, 5, 6, 7. Okay, and this is 8. But why is not aligning then? 1, 2, 3, 4, 5, 6. Okay, 7. This is 8. Sorry, my bad. Okay, so this is 128, but this is a negative number. Fine. So because it has 1 in front of it, and we go through all these bits. The rule of 2's complement is we go through all these bits and shift. We see the first bit, let it be as it is, then go again left, and we uh, quit, and we flip the bits. Okay, and then whatever we get, we do the binary of it, and that would come as 128. But because it was a negative number, it's minus 128. Okay, so now you can see like 127 went to 128, but this is a negative number, so we have to do 2's complement, and doing 2's complement makes it minus 128. Okay, so is this clear? Like, I was trying to align all this, my mind got jumbled a bit. 8 bits, 9 bits, all that. So is this clear? Like, anyone would like to say contradict that this is not 128? Then I have to do some like explaining. If everyone can understand this is minus 128, then it's fine. Then you won't need that circular representation. But still, if you remember with that circular representation, it's very easy to understand. You don't need to have 2's complement knowledge. So whenever we do 127, we go out of range, we simply go to the minimum most value. Okay. So, but the problem with 2's complement is that, let's say we store a number like 134. Now you have to do the 2's complement on this number and find out what is its negative value. And that's a very hectic process. So my circular technique, it's not actually mine. One sir taught me this. So 134, okay. So 134 doing 2's complement would take a lot of time. But what we do is, what is 127? 134. It's 127 plus 7. Sorry. 127 plus 7. So 127 plus 7. So we do 127 plus 1, we go to minus 128. Add one more, we go to minus 129. Minus 130, minus 131, minus 132. Basically, 127 plus 7 is minus 134. And the difference between this and this is 6. So we subtract 6 from this, and this is gonna be 122. Let's see. Let's see. This is a lot of jumbling. It's better we type in here. I think now my class has already started to go bad, I guess. I don't know. Let's see. 134. Yeah, see, minus 122. So basically what we do is we find the difference of this from 128. So 128, this comes as 6, and this 6 we subtract from us. Don't subtract, we add with minus 128. Okay. Okay, this equation makes no sense. I'm just writing uh, like this. Okay, I'll delete it instantly. Okay, so I'll repeat what you have to do if this goes out of range. So now the 0 to minus 128 to minus can't be too many. So again, same goes for here. Each value from minus 128 to minus 1 is assigned a character. You know why I mumbled here a lot? Because there were a lot of WhatsApp messages and I thought I was going somewhere wrong, and I tried seeing a message but I could not. So I came back and I was doing this for 2 or 3 times. I neither saw the message nor was doing the calculation, and that's why you saw me mumbling a lot. Okay, so okay, never mind, we'll go ahead. Each value from minus 120 to minus 1 is assigned a character. And there are no control characters. Everything from minus 128 to minus 1 is printable. No, nothing about control characters. So what I was actually telling you is the formula to convert this minus to a positive number without 2's complement. Okay, so first step is This will be useful for you. You know, if anyone asks you what is the ASCII value, I mean, gives you like minus 134 and asks you what is the ASCII value in positive, then they probably are asking you to calculate a two's complement. But if you know this, then you don't need to do all those hectic two's complement calculation, flip the bits, do all this, that. You don't need that. Okay, let me, oops, my bad. Sometimes windows don't work as you wanted to. Anyways, first step is we find the difference. Let's say let our number ASCII value be 656 already. Wow, time really goes too fast. Sorry, not 134. First step is we find the difference of the given number. Let the number be an ASCII value. So find from 128. Sorry, this will be minus. Okay, so I know a lot of things happened here. If you have doubts, please tell. Someone should have a doubt, I guess, because I don't think I was very clear about this. And also, if you think two's complement is easier than this two steps, you can also say that. Uh, or say like, which step do you think is easier, two's complement or this? I mean, this will always work. It will never fail you. And this even works for integers and all. You'll probably have a homework to show me how what happens when integer value goes out of range. Okay, never mind. Any doubts? Probably class went off because how I was teaching. This is easy. Okay, this is easy. But do you have any doubts regarding whatever happened here regarding the two's complement as well as the normal this method? Okay, I hope it's clear. Anyone else like only clear? No, it's clear. Okay, Iram Sakshi. Like only this people only respond in my class, I guess. Like I have never seen uh, new faces or someone else. Like from the last two classes, I've never seen someone who have not heard of from. So like Vaishnavi said, after a long time, it's clear. Okay, so fine, nice to have you back, Vaishnavi. Clear. Okay. Some people don't forcefully write clear. If you don't think it's clear. No, Orgo, you are in the list that always responds. I'm seeing you from the first class, so don't worry about that. I'm just saying that I haven't seen new faces. So Jishnu is probably a new face today. I'm seeing. I haven't seen Jishnu. Okay, clear हो गया. Nice, clear हो गया तो बहुत अच्छा है. Okay, I'll remove this two's complement because you guys were more pro in two's complement than me, I guess, because I mumbled a lot here, trying to see WhatsApp, trying to say this. Anyways, so I see every day the feedback. People tell me to be confident. I try to be, but still I'm scared that I may say something wrong, so that confidence goes out of the window, like that. So, but I try. Anyways, so characters are done. Okay, now we'll see some neat tricks on characters. So I will show you this character list again. Uh, Probably you remember 65 is capital A and 90 is capital Z and 97 is A and small z is 122. Now, question, what do you do if I say convert this to a small letter, to small a? What do you do? In any language, those who know other language, say what do you do in other languages. In Java, you probably use toLower. In C++, you need to add a library, then use toLower. You can't directly do that. But do you have any other ways how you can do this? I'd like to know. Those who know any language or ever face this, how to do a smaller letter. Other than functions, do you know anyway? Like toLower, everybody knows who has done Java. In C++, you can do tool lower, but you have to include a library. Using ASCII code, exactly, typecast, then add or subtract. Okay. Actually, character gets automatically typecasted when you are working with integers. So you don't need to, because at the back end, a character is an integer. Change the ASCII code value by adding or subtracting. So would you like to say what is the number? What number we should add or subtract? 65 plus 32. Nice. Now what if I say that you can't use this number? What did you do? Like you don't remember this number. Okay, forget about remembering. You don't, I won't let you use this number. What did you do? Is there any way you can still do it? Or is there no way? This is like a final part of characters. Then we'll move to bitwise. Probably class would get extended. No, you can't use library, you can't use numbers. You know, class can't be like all I'm talking, you guys are just listening. You have to think something as well. So that takes time, but I think we can give that time. Like, what would even happen in 5 or 10 minutes? Okay, no, anyone, no one would say. So the simple thing to do is, okay, this is we are converting this to a lower character. We do space, uppercase, lowercase, something I'm not sure. Okay, we can't use can't use library functions, and using library functions, that to lower function is even more tougher in C++ because you have to include something called CC type, then you can do it. Okay, but this is such a neat trick. I'll show you. Wait a second. Okay, sorry. Probably I just print the character. It's showing the ASCII value, but I can do this. It see got converted into smaller a. I did not use any functions, no ASCII values, nothing. Okay, just added a space. It got converted to a small a. Similarly, if you want to convert it to a smaller uppercase, you just uh, minus space from it and you get this. So the problem, like a lot of people don't know, forget like the difference between a smaller and upper is 32. But you'd always remember space, right? How can you even forget a space when it's right there on a keyboard? So you'd never forget, no chance of forgetting a space. And a lot of people don't know the space is actually 32. So this is no magic. The ASCII value of space is 32. We are just abstracting it. But this is a different way of doing it. You can do all of the ways, no issues. You can use CC type, then do tool lower. But why do you include so many things and do so many hazards when you can just type these two things and get done with it, right? No use. So I would just prefer this method. Okay. One more thing is that if this is one, this one, okay, no. Anyways, so this is a one, and this one is not equals to this one. I'll show you why. See, do you anyone thinks that this one can be equals to a character one? Anyone? Oh, it's not a shortcut. It's just a neat trick. Okay, and probably not a trick as well. Space ASCII value is 32. A lot of people don't know that. Okay, not at all. Right? Yeah, it will give 0. Not at all. But what can we do if we want to? I mean, what do we need to do if we want to convert this into a 1? Can we just assign it to C, and do you think it will magically get converted? What do you think? Like, this is the interesting part. See, data representation part is really tough. Okay, reason for no. See, 1 is a character. Fine. This one is a character and its ASCII value is 49. But this one, its value is 1 only. So you convert this 49 into binary, you get something. I don't know. Okay, probably got to do binary calculation then, but whatever. You'll get a binary, which would of course not be equals to 1, because 1 is like 000 32 31 bits and then a 1 dot 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 31 bits then a 1. So how can this binary code equals to this binary code? Can it be, Sarika? Uh, can you say that it will be now? Did you understand? Like the reason for no? What I meant to ask is, did you understand the reason for no? Yes, I got it. Thanks. Fine. So if we store this ASC, do you think it will magically now display 1? If I see out A, class is getting extended, so I would just do it myself. No, the answer is no, it does not. Because as I said, the value assigned to this is 49. So it will just store 49, it will get converted to int. That int value is 49, not 1. 1 is a character between quotes. That's why I've written this between quotes. If this was only this, then it would have been fine. But between quotes, it means 49. 49 and 1 cannot be equal. So we are assigning A to 49. So obviously A would print 1, I mean 49. Okay, it's giving the code as an output. Yeah, but I am saying like what to do if we want to convert this character to its digit format. Like I want to convert 1 to 1. Okay, we can't assign this, we already saw, because assigning would give, as Orgo says, the code, or rather the ASCII value, because when it typecasts, the typecasted value is 49. So it stores 49. So anyone has any idea? Another neat trick, I should say. Okay, so no one has no idea, I guess. So I'll show you. Wait. You see minus 0. Now see. Yeah, probably. I mean, anyway, you can change it, not this int, but you have to store somewhere. No, you have to store this 1 into an integer value. Somewhere you have to store. I mean, even if you create another char, then you have to store it. But before storing, you have to convert it. Without converting, you cannot store it. And even if you convert, you have to store it somewhere. So what we do is we subtract 0. The logic is you have to always understand the logic. Did you get the logic of the last one? That was no magic. Okay. As Monal suggested that we should plus 32, we added space whose ASCII value is 32. We did no magic. Yeah, pure logic, no magic. Nice. Okay. So whatever Monal said, that is exactly that thing. We added 32, but sometimes you can forget like what is the difference. Then you calculate like 97 minus 65. No need to do all that. Just add space gets converted to lower character. Add subtract space gets converted to upper character. Yes, 49 minus 48. So I'd like you to show this table again. I would zoom even more. I know it's blurry probably. See, 0's ASCII value is 48, and this gets converted to 48. This was 1, which is 49. Now 48 minus 49, I mean 49 minus 48 is 1, and this would work for any character, any number. Okay. Why am I? Okay, sorry. 9. 9 does not get stored. What? Empty character constant. Why is it showing empty? It's absolutely not empty. What is this? Come on. Yeah. What was that? Like I typed exactly the same thing and it showed empty character constant, and then I typed exactly the same thing and it worked. Okay, whatever. I've never seen anywhere. I never seen anything like this before. That's why I don't like VS Code probably. And Manish Pawan and Kajal भी like VS Code को मौका मिल गया छोटा करने का. Okay, never mind. So did you guys understand these two conversions? Let's be serious for a second, uh, or for the rest of the class. 5 minutes already above the extended time, or 4 minutes. Yes, you understand. So uh, the way to do it, if you don't know, was to call some library functions. But for that, in C++, you have to know which library functions to call. In Java, you include util and everything is there. But in IOStream, those things are not there. So you have to call CC type, then 2-digit, 2 upper, 2 lower, and you do all that. But you don't need to. You just type this and things get happened. Why? You know now. Nice. So moving ahead, I said we'd complete characters and then go back to then go back to our bitwise operator. So guys, I would like to ask again, can I extend the class like for more 5 to 6 minutes? Okay, that's great. Can I extend the class for like 5 to 7 minutes? So like we at least can cover something. Yeah. So whoever said like last class, please don't extend the class. I'm really sorry. Uh, no, I mean, if you want to say no, you can say no. The solution for your problem would be like, you should leave the class if you have something urgent to do, and then see the class recording or read the notes. And if you have doubts, you'd come back. And if you have no work, then you'd stay with me. Fine. So every problem has a solution. Uh, Mostly, not in all cases. Anyways, uh, okay. So bitwise operators, guys, clear everything in your mind about characters. Just forget characters. Class is amazing. Class is bad. Extend time. Extend not time. Forget. Leave. Just think. Just concentrate on bitwise operators. I know you don't know what a bitwise operators, and even if you don't, even if you know, that's fine. But just think that there is only thing right now, that is bitwise operators. That class is bad or amazing, whatever. I mean, if the class is bad, you might have left. If the class is amazing, you might have stayed. Whatever. Concentrate on bitwise. So first bitwise would be this. This is called a logical or. Okay. So sorry for those breathers. I take sometimes, but I need to. Anyways. Sorry, this is not a logical one. My bad. It's a bitwise one. Oh, yeah. Sorry. Bitwise and I guess I'm not completely into bitwise right now, so I need to focus like for like 1 2 seconds, 1 2 3. Okay, let's go. Okay, fine. So what bitwise does, bitwise and does is takes 2 bits and 0 and does the AND operation. So does everyone know Boolean algebra? Like what is a AND operation? Do you all know in Boolean algebra what is a AND operation? Or is there anyone who does not? If you don't, you would say no. If you know, you don't have to say yes. So anyone who does not know what is an AND operation, don't say yes, don't say yes. Just for those people who want to say no. Like, like if I want to say no and I see all this yeses, it demotivates me and I then don't type no. Because I'd be like, so everyone knows, but I don't know. That is bad. So like from now on, explain. Right. Follow, be like Quena. Okay. That's what you want. So AND operation. Probably this would extend the class a bit more. So AND is like a multiplication, and our set is 0 and 1. So as I said, we are working on binary. So 0 and 1 are the only things we know. I mean, we are working on bits. Bits is binary. So 0 and 1 are the only possibility here. So let's say 2 bits are 0 and 1. If we do AND between them, you can think it as 0 into 1. And what would happen? 0. Don't make the mistake I did last time. Multiply 0 into something and write the right hand side. No, that was a mistake. Okay. Okay, so I have to write a definition. So Kajal, did you understand? And Koena, did you understand how this works? I'm writing the definition, but AND operation is like a multiplication, but between 0 and 1. Probably you would. But what about Koena? Yes, okay. Okay, so write the formal definition. So Koena, question for you. What would be 1 and 1 first while I write this definition? And what would be 1 and 0? What is this? And equals to star. Is this some kind of a secret code? Or is this a very another neat trick or something? Okay, Quena is right. So Quena understood this. Fine. Monal, can you explain what is this? And equals to star. What is this? Nothing, nothing. Okay, probably I did not understand. Never mind. I would ask you later. It is and does the AND operation. probably I have to increase my mistakes that I wrote this as OR. Okay. 716. The AND operation. Right. AND operation works as a so this sign is called bitwise OR. So like you can see, like logical takes 2, bitwise is 1. Okay. Sorry, it takes 2 bits. So now the OR operation is equal to AND. Oh, okay, nice. Okay, yeah, AND is actually represented by a dot in Boolean algebra, but just so you understand right now, that's why I did that star. Okay, AND is represented as a dot in Boolean algebra. But like when I said to explain, so probably she does not know Boolean algebra. So if I write dot, you'd be confused. She would be confused. So I wrote star. Okay. So yes, AND is represented as a dot. Anyways, 2 bits, and that's the OR operation. So OR operation is the plus. Okay. This is actually more tough than AND. Why I will tell you. So we do 1 plus 0, we get 1. No issues about that. We get we do 1 plus 0 plus 1, we get 1. No issues about that. But what happens when we do 1 plus 1? Like Boolean, I mean binary can't store 2, can only store 0 and 1. So what would happen? Yeah, 1. Like, does anyone not know how does 1 work here? I mean 1 plus 1, what does 1 plus 1 give in binary? Okay, Quena knows it gives 1. That's nice. Okay. So I hope you all know that 1 plus 1 is 1. Okay. So how this works is like 1 plus 1 is converted into its binary, and since we can only store the 1 bit, we take its more significant bit. Fine. So that's how it works behind. Nice. Moving on. We'd leave one operator for today, that is the negation operator. To explain that, we again need to go back to 2's complement. So we'll leave that for now. Okay. What more is left? And or XOR, right? Logical. Why do I write logical? X. This is XOR operation. Okay, so XOR operation does not, I mean, it cannot be represented as an equivalent to any of the mathematical representation. XOR operation is writing this below this because it's a bit big. XOR operation is one when both when the bits are different and returns zero when the bits are not different. Okay, so wait a second. Probably I can close this. Okay, so I would give you the task to understand if you have understood or not. What happens when you do? Okay, this is the sign of XOR. Okay, what we use as power is the sign of XOR. What happens when you do 1 XOR 0? Answer. 1. Fine. I have not erased this. 1. Fine. What happens when you do 0 XOR 0? 0. Any more zeros? Zeros. Zeros. Nice. What happens when you do 1 XOR 1? Yeah. What happens when you do 1 XOR 1? 0. Nice. You guys got it. Fine. I would like keep this here. A lot of people don't know XOR or forget XOR. So if you ever forget and you have my notes still, you can just open day2.txt and read this. Okay, so you don't understand. Fine. 3. Oh, sorry, we already did 3. Okay. Another interesting, very interesting operator. So this is also a bitwise operator. Okay, so explaining this would be a bit tough. 7:20 already, maybe like 2-3 more minutes. You know, you are probably thinking, but you are saying this 2-3 more minutes for so long. Okay, it takes. Okay, now all these things can actually work on numbers as well, not bits, but it goes bit by bit. The operation goes bit by bit. So like say if you have a number 7 which is equals to 111 and the number 5 which is equals to 101, and if you do any of the bitwise, the operation goes bit by bit. So say we do 7 and 5. First it does 1 and 1 which is a 1. Then it does 1 and 0 which is a 0. Then it does 1 and 1 which is a 1. So 7 and 1 is 5. We'll just check this, and if this is a mistake it would like increase my mistake. Let's see, where is the like why did not print anything. Okay, why is printing 1? Okay, sorry, I did 7 and sorry. See, 7 and 5 is 7 and 5 is 5. Okay, just as we calculated. Good thing my mistake count did not went up. Yeah, single end, right. I realized that. That won't be counted as a mistake. That was done in a hurry. Okay, so it takes 2 and shifts the bits. Uh, oh no, okay. Okay, so it takes a binary number and shifts the bits n number of places to the left side, where n is the right hand value. Just write it here. I just write it as r value. Okay. Okay, so let's see a example with 4, which is 100, and we would do the operation left shift. Oh, okay. So another neat trick. If you forget what is left shift and what is right shift, as I said in the very first class, see where the arrow is pointed, and that side is that is the side that arrow points is the side of the shift. So this arrow points to the left side, so it's a left shift operator. Okay. Someone might have a problem like me that who forgets what is right and what is left. So for them, this would work. So this is the thing, 100. Okay, this is the last topic of the class. I won't extend it above 7:25. No ways. People would probably be throwing stones when I go to college. So I don't do that. Okay. Okay, so now you know a way to remember. Okay, so 100 is 4, shifting by 2. So as I said, the it shifts the bits n number of places to the left side. So the first bit is 1. So if it shifts to the left side, like there is nothing to the left side, right? So it vanishes, but the bit number will stay the same, and you can fill this with 0 only. Okay, so okay, am I doing something like left shift? Wait a second. So 100 shifted by 2 places. This, am I confusing between left and right again? No, I guess I'm not. So okay, yeah. Okay, so it shifts the bits means it adds bits. I mean, this one is shifted. So no, it does not vanish. I said wrong. So one is shifted one place uh, before it. So I'll write the place values. So this is 2, 1, 0, right? So one is shifted 2 times to its left. So once would be 4. Fine. This would be 3 and this 0 would be 2. So now we have 2, 3, 4 for this, but the binary place must start from 0, right? So we need to fill the gaps. Like we need to have something at the 1 position and the 0 position, and we fill it with 0. Reason it's that 0 adds nothing to the value of a binary. Okay, that's the reason, because 0 is considered as a non-value changes, so it can't change the value. But here you'd see the value actually changes, but if we did 1 here, that would be undefined. So we always fill the leftover spots with 0. So now you'd see what happens is that this is actually 16. Okay, so if you don't want to remember all of this, how left shift operator works is left shift operator is equivalent to, okay, last topic. No ways we are extending the class above this. Beyond this, left shift operator is equivalent to, even I'm getting tired, multiplying the number with 2 to the power n. Okay, see, so even I forgot left shift and I was doing right shift. So if you remember this, that it multiplies with 2 to the power n. So we are doing 4 left shift 2 equals to 4 into 2 to the power 2, which is 4 into 4, which is equals to 16. Okay. We just see this here. Sorry. See, we get a 16. Fine. Okay, I mumbled a bit there. So is there any doubt? Okay, how? Okay, see, we are shifting the characters. So the place value alters, right? This was, okay, right, let me write the original string. 4 is equals to 100. The binary representation of 4 is 100, right? Just remove this. The place value of this one was uh, 2 and desktop bit was 0. But now see, the place value has become 4. So you convert this into the binary. You would be like 2 to the power 4 into 1 plus. Okay. Oh, as I said, I've written this. N equals to the right hand value. Okay. So when you do an operation, so it has a right hand and a left hand value. No, it's not 2 to the power 4. No, 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 no. Okay, I'll recap. Operator has a left hand value and a right hand value. Okay, so here this is the right hand value and this is the left hand value. So this is what I'm saying as n. As I said, n is equals to r value. And I have said it takes a binary number and shift the bits in number of places to the left side, where n is equals to the right hand value. So for left shift 2 shifts all the bits. Uh, this will be all the bits. Shifts all the bits 2 places to the left hand side. So you see, we have shifted 2 places. This was 0, this became 2, this was 1, this became 3, this was 2, this became 4. Now, if we convert this to our binary representation, this is like 2, okay, to the power 4, like how you do in binary, 2 to the power 4, 2 to the power 3 into 0 plus 0. I mean, all the rest will be 0, obviously. Okay, this is 16. Any doubts? You may have doubts, you should have doubts, you can have doubts. So you can ask. Okay, same as binary. What do you mean by same as binary? Hiram. See, left shift 8, left shift 3 is would be like 8 into 2 to the power 3, which is 64. Okay, so okay, I don't think this was clear. 2 to the power 4 into 1. Yeah, but I've written that. Yeah, I don't understand this. Fine. See, I've written 2 to the power 4 into 1. Okay, so let's see. Uh, again. Okay, that's fine. You can go. Even I have to go, but whoever does not understand will stay. Pawan, you can share the feedback form, and you guys can leave as well if you have like something to do. Yeah. So fill the feedback form. I mean, if you want to leave, you can probably see the recording later or come on Discord. So what is happening here is you all can agree that force binary is 100. Fine. You have to now respond like yes or no fast. Those who don't understand. Those who understand, for them it's okay. 4 binaries is 100. Fine. So I remove this. Now see, the you know what the problem is, like I can't draw the, I mean if it is a board I can write this is the number and this is the place values, but I'm still trying, place values. So can you understand this, that the place value of 0 is 0, this 0 is 1, and this 1 is 2? Yes. Okay, so this says that it shifts all the bits n number of places. I would remove this. So this is what we are doing. Okay, our task is this, doing 4 left shift 2. 4's binary is 100. The place values are 0, 1 and 2. You understood till this? Now it says that it takes a binary number and shifts all the bits n number of places to the left side. Fine. So this bit, it shifted to the left side, but something then has to come at the right side as well. No, now the place value has become like, okay, the left side, you see this is like going 2 spaces. I want just 1 space. Yeah, so 1 is shifted 1 space to the left side. Fine. So now the place value of 1 has become 3. Do you understand till this part? We have just shifted one part, 1 to its left side by 1 place. So but now this 0 is empty. Fine. If this was a board I could pinpoint, but I can't, because if I switch to my pen I can't switch to my but this 0 place is empty, so you have to fill it. We can't leave it empty, so we fill it with 0. This is what is a 4 left shift 1. We have only shifted one, I mean all the bits by 1 places. Now we would like to shift all the bits by another 1 place, so it becomes 4 left shift 2. So this is this. Okay. We are shifting 1 by 1 place, 0 by another, 0 by another 1 place, and 0 by another 1 place. Again you see this 0 value is now empty, so you have to add a 0. And this is 4. Now you convert this into binary, you get a 16. Am I clear, or is there doubts? Guys, okay. And okay is like a bit of a problem, but you know what you can do. Try this at your home. 6 left shift 2 should be your homework. I would leave this here. Number. Trying my best to explain this. What is 4? Yeah, you are using the Python representation. So yeah, it's right. Python star star is power, I know. So yeah, you are right. Sakshi is right. But for the others, try both of this at your home and probably. Oh, sorry. No, no. That would be ridiculous. Okay. So this is this. Probably not. Okay, I'll just remove this example because I cannot write it here properly. Just do this. Just try to do both of this at your home. Just as I showed, you write the binary, you shift the places, and whatever place now remains, you'd fill it with 0. Like whatever place gets empty, you'd fill it with 0. Still, if you have any doubts, you can ask. This is the end of our class, actually. Okay. Anyone has any doubts regarding this left shift? I know it's confusing. Yeah, you'll get the notes, as I said. No worries. Probably the left shift operator is more of my concern that if you have understood or not. Yeah, okay, bye. Fill the form on your way. Feedback. Okay, so this ends the class. If you still have doubts, like you can ask anything, like left shift, how still left shift works. Yes, I understand everything. Hopefully, hopefully you do. That would be nice. Still do this. That would make it more clear, you know. Like without doing exercises, nothing can be clear. And programming is a subject like you understand by hit and trial. You try, get errors, then try again. You learn like that. Okay. So you can leave the class probably if you want, or you can. I would stay here for 3 minutes, 7:40, and you can ask any doubt if you have, or leave as you want. Welcome and thank you to you all as well, because like this class was the class length is increasing day by day. Let's hope it does not. Uh, Next week the class can stay within its limit only. And I'm sorry for extending the class. That feedback, like you can think that feedback, I did not take your feedback seriously because the class was extended even more. But like if people have doubts and I end the class, I can't do that as well, na. That would be hilarious. Like what teacher would do that? Can't do that. So college teachers would probably say, come in WhatsApp. Yeah, I'll clear your doubt or in next class. But it's pointless to leave with a doubt. Anyways, you can leave. I'm just talking nonsense right now. Yeah, we extend by 37 minutes. Uh, Not 37.